few general points about logistic regression. Particularly if you fit a lot of, if you were to use all the variables in your model, you might get quite good predictions on your data set, but would it predict well on another data set? If it's important to know that you're going to predict well in the future, you would want to test your predictions either using another data set or to use something that's become known as cross-validation, where you take out subsets of the data in turn and then you train your data on one part of a data set, test it on the other part of a data set, so you get a fairer assessment of how well the model is likely to do if you were to use it on a separate data set. So it can be a bit deceptive. If you were to put a vast number of variables in, you got almost perfect predictions, you might think your model's doing really well, but you put it on another data set, it may not do anything like as well because you've got overfitting. And if you've fitted a lot of variables, you need to bear in mind you're adjusting for a large number of variables, so you need to take care when interpreting the results for individual variables. So for example, if we just fit peripheral vascular disease on its own without doing any adjustments, we get a really high odds ratio. When we adjusted for age, gender and smoking in the model we just had, the odds ratios, well, it's still definitely significant, but it's not quite as high. But you might think that was appropriate. Age, gender and smoking, they're not medical measurements, so you do want to be sure that the groups you're comparing are peripheral vascular disease are similar in terms of age, gender and smoking, so that probably was a sensible model. But if that model that adjusted for all other variables, the odds ratio for peripheral vascular disease actually became non-significant. It's still greater than 1, so there's still estimating more odds of death on peripheral vascular disease, but it's not significant. And in that case, you've probably over-adjusted because you've adjusted for all sorts of other types of disease, including cardiovascular diseases, and which are associated with peripheral vascular disease. So you've probably got rid of some of the effect of peripheral vascular disease that you're interested in. So you need to be a bit careful if you're interpreting the factors in your model to bear in mind what you've adjusted for. This is just a note. I think last time I said if you've got a confidence interval and it didn't overlap 0, it would be equivalent to having a significant result at the 5% level. Well, for odds ratios, the equivalent number is 1, because an odds ratio of 1 means there's no difference between, say, smokers and non-smokers, and an odds ratio of greater than 1, you've got a higher risk. But if this confidence interval that you can get for your odds ratio, if it doesn't overlap 1, it's equivalent to having a statistically significant result. And so it's only the last one where we adjusted for absolutely everything. Our confidence interval now overlaps 1, it's quite wide, and we've got a non-significant result to go with that. So that's just to show the analogy we've got a similar analogy between confidence intervals and significant results, even when doing logistic regression.